All right, now to solve a radical equation, you gotta remember a little bit about exponents, and we've talked about exponents already this year. Fractional exponents just means the top number is a power, the bottom number is the root. And when we solve radical equations, we'll be talking more about using that. A radical equation contains a variable within a radical. Recall that you can solve quadratic equations by taking the square root of both sides. Similarly, radical equations can be solved by raising both sides to a power. So in order to solve a radical equation, step one, we want to isolate the radical. So that's very similar to when we were solving absolute value problems. You want to isolate the absolute value equation. Same thing here. We want to isolate the radical. Then we want to raise both sides of the equation to the power equal to the index of the radical. So for example, if it's a third root, we want to take it to the third power. If it's a second root, we want to take it to the second power. If it's a fourth root, we want to take both sides to the fourth power. And then we want to simplify and solve. So in this problem, we want to isolate the radical. Okay, what does that mean? That means that we want to get the radical all by itself on one side of the equation. So in this problem, I want to isolate this. I want to write a little bit smaller here. Okay, so what I really want is I want to have the square root of x plus 1 is equal to something. Okay, well, that means that 5 has to go. I'm going to subtract 5 from both sides, just like solving any equation. So 16 minus 5 is 11. All right, so now anytime there's not a number in front of the radical sign, it's assumed to be a 2. It just means that this is a square root. If there was a 3 here, that would mean it's the third root of If there's a 4, it means it's the fourth root. But if there's no number in front, it just means it's a square root. So how do I get rid of a square root? I square both sides. So now the square is going to take care of the square root. I'm left with x plus 1 is equal to 11 squared is 121. Subtract 1 from both sides. I end up with x equals 120. Now, can I check myself? Absolutely. Put that in there. So put 120 in there plus 1 is equal to 16. Okay, so the square root, so that's going to be 121. So that's going to be 5 plus the square root of 121 is equal to 16. The square root of 121 is 11 is equal to 16. 5 plus 11 is equal to 16. That is the correct answer. So yes, can you check your answers? Absolutely. Go back and plug them back in. Not a problem. In this problem, same thing. I want to isolate the radical. Well, in order to isolate the radical, I'm going to subtract 4 from both sides. Left with the square root of x minus 1 is equal to 1. Now I'm going to take both sides to the second power. So x minus 1 is equal to, well, 1 squared is 1. Add 1 to both sides. X equals 2. I'll plug it back in there and solve, and you will see that it does work. So solving a radical equation is not that bad. In this problem here, now I have a third root. Well, the radical is isolated. There's nothing, there's no 5s on the outside. There's no numbers on the outside. So in order to get rid of the third root, I'm going to take both sides to the third power. The third power crosses off the third root, so I'm just left with 3x minus 4 is equal to 2 to the third power. Well, 2 times 2 times 2 is 8. I'm going to add 4 to both sides because I'm going to solve for x. So 3x equals 12. Divide through by 3, x equals 4. And you can plug it back in there and it will work. So it's a good way to check your answers all the time. So in this next problem, this 6, it's 6 times the square root. It's not the sixth root, okay? So sometimes it's a little bit misleading when you read some of these problems. So I need to isolate the radical, so I'm going to divide both sides by 6. So I'm left with x plus 10. The square root of x plus 10 is equal to 7. I'm going to square both sides now to get rid of the radical. So I end up with x plus 10 is equal to 49. X equals 39 because I subtracted 10 from both sides. Now, if you have a radical on both sides, there's no way to get rid of this 3. However, this is where it gets a little interesting. I'm going to square both sides right now. Okay? So if I square this side, it's pretty easy. If I square this side, a little bit more difficult. So if I square this side, I end up with 7x plus 2 equals. Now, if you square this side, you have to square, because this is really 3 times the square root. You have to square both things in here. So I have to square root of 3, so that's going to give me 9 times, and then 3x minus 2. Oh, that's interesting. So now I might multiply through here because this is not a radical anymore. So I might just rewrite this as 7x plus 2 is equal to 27x minus 18. And then I'm going to solve for x. I might subtract 7x from both sides. So 2 is equal to 20x minus 18. I'm going to add 18 to both sides. So 20 is equal to 20x. So x equals 1. Now, this is where I might check my answer because, you know, it's like, wow, 1. So I'm going to put 1 in here. So 7 times 1 is 7 plus 2. That gives me the square root of 9 is equal to, and then I'm going to put 1 in here. 3 times 1 is 3 minus 2, that's 1. So I end up with this. Okay, so that's what I end up with when I plug it back in. Well, the square root of 9 is 3. 3 times the square root of 1, well, the square root of 1 is 1. So 3 is equal to 3. Yeah, that does work. So my answer would be 1 for that problem. Okay, so just watch that little trick there. You've got to square that number there in front too. So here's another one very similar. Again, if I was doing this problem, I would square both sides right away. So if I square this side, I end up with 8x plus 6. If I square this side, I end up with 9x. Okay, because you have to square the 3, and then the square root of x squared is just x. I'm going to subtract 8x from both sides. So I'm left with 6 equals 1x. So my answer should be 6. Right. I think we did this. Okay, so let's try this one. Very similar to what we've been working on. So I'm going to square both sides. So if I square the left-hand side, I'm just left with 3x plus 2. If I square the right-hand side, I'm going to be left with 9 and then 2x minus 2. Now, it's no longer a radical problem, right? It's just can you solve an equation? I'm going to multiply through here, so that gives me 18x minus 18. Here I have 3x plus 2. All right, I might subtract 3x from both sides. So I'm left with 2 is equal to, what is that, 15x minus 18. Then add 18 to both sides. So 20 is equal to 15x. Divide through by 15, I end up with 20 over 15, which is, what, 4/3? And I'm done. That is solving a radical equation. All right. Hope to see everyone on Monday for our main lesson. You guys have a great week. Bye.